Welcome. Again, I'm Larry Coldiron, and hopefully you'll get some value from this course, assuming that you stay through the whole course. But anyhow, yeah, a little slip of the thumb there, but ICND1, CCNT, why this? The number of Cisco certifications, professional certifications that require this, or what, CCNA, CCNA Security, CCNA Wireless, that in order to take those certifications, you need the entry level course, CCNT or ICND1. To get the CCNA, you take the second part, which is ICND2, in order to then become a full-fledged Cisco certified network associate. So what is a network? And for many of you this is going to be insulting, and I apologize. Maybe for everybody this is going to be insulting, and again I apologize. But what is a network? And one of the things, and I love to use my pen here if I can get it working, we're connecting users and sharing resources, and that's what it's all about. Home office, we may be just the network here, we may be getting resources on the network, maybe just the internet, going to a website or whatever else. But we have our home office here. We may actually be connecting to a large enterprise office. If we're working for home, we're a home worker. Which is what a lot of people want to be, so that you don't have to get out into the traffic every morning. Branch office of the enterprise office, that we're going to connect these guys together across a network. And you notice we always show this great cloud here. You may or may not, with the Cisco certifications, be working in this cloud. This is where the ISPs are going to be. More than likely, at least to start, you're going to be here as a part of this, or maybe the only individual, the networker in a small business. I've had a number of students went to small businesses and they own the whole thing. They own the servers, they own the routers, switches, workstations. They were responsible for all of it, and most of them really love that sort of arrangement. But in order to do that, you need the background in order to maintain and fit together all of these devices. And that's a big part of what all this is. How do all of these things fit together? How do we manage what goes on in each of the activities? And that's what the course is all about. The networking perspective here, again, probably maybe insulting, but the home user, we were looking at our laptop, maybe going to a wireless, or maybe the PC to the wireless, PC to the wired connection, through our cable modem or DSL modem to the internet. And that's where we're gonna go do what, Facebook, or maybe Twitter, or Google for searches, or Bing, whatever. We may be maintaining websites, whatever else. We're going to the internet from our home. Not a complex network here, but we could have, if we wanted to, we could have other devices connected to this wireless router in order to expand our home network, and you should be able to do that too. So the home user, the enterprise view, a little bit different. It's kind of a simplistic view. We have a PC to a switch to the enterprise network. The enterprise network, first thing we're going to have in here is our router to get us into location to location, and a router at the other end, and we're going to be able to send the traffic through this magic cloud using we're going to talk about the models here in a few minutes. OSI model layer 3, which is where IP addressing is, and the IP addressing is what the routers are going to use to get from point A to point B. We'll also get into switch management a little later in the course. Make that go away. And then the next one, the devices that we're going to use, a hub, which is legacy device, and everybody knows legacy means old, and hopefully you're not going to have that. We're going to talk about layers here in a minute, and this is just, hopefully we'll build on. I'm going to introduce terms that kind of make no sense right now, but hopefully we'll in a few minutes. But layer 1, switch here and a bridge, and switches and bridges are related when you get into the terminology. What they do is isolate what's called collision domains. In a hub, and you're gonna see this bad image multiple times, but a hub is what's called a bus. Much like, and somebody said one time, like a bus line, it just goes down the bus line. Yes, it does. But all of the devices are connected to a single piece of coax when we do that. In the switch, we're going to break all this up so that they're not all connected to the single device, and this is called a collision domain. Collision domain. And the switch is going to create multiple collision domains so that we don't have those collisions, much like a city street that has two-way traffic, and maybe we put a one-lane bridge in it where we can transmit. We can go each direction, but across the one-lane bridge we can only one can go at a time. A switch would be much like an interstate highway. And then we're going to have routers, which are going to find, they're going to be at layer 3, which is going to be where the IP addresses are, and they're going to be able to find networks where the resources are so that we can get to the Google or to the Microsoft device or to the Yahoo or Google Udemy in order to be able to use the resources that are available. A really basic network here we're looking at, and this is the one that I sketched, a very basic network. This is a single piece of coax. These devices would be connected together in what are called T connectors, so that the T connects to the NIC on the device, and then coax to the next T connector to the next device. Problem with this one, any break in this, and it brings down the whole network segment. What we do with a hub here, it's still going to be a very basic network, is if we drew a box around this thing, this piece of coax, and shrunk it into a box the size of a hub, then we still have the same arrangement, and that's exactly what happens here. And this says everyone can hear you. As you can see here, if we put something on the wire, it will be available to all of the devices that are on that bus. We'll go through how the device only accepts traffic that's destined for it. But if we have here, hey Mary, Henry sends something to Mary, and if George is here, George is also going to be able to see that traffic that goes there. So not exactly the most desirable situation when we look at those. If we add a switch, switches do something very special in that they create, they segment with the switch, creates collision domains. So that in that case, the hubs here, everybody hears everything, and when we get over to the switch, we're going to have an address at layer 2, and these are going to be layer 2 devices. And again, we're going to talk about what this layer business here is in the next couple of topics. Layer 2, we're going to do this. We're going to create a list of layer 2 addresses so that on a switch, the traffic only gets sent to the devices that it's intended to. Everybody doesn't hear it. So we're going to create a collision domain on each port of a switch. Lots of collision domains, and in this case on the hub everybody hears it, the traffic gets over here, the switch says, oh, I don't have this guy on this traffic, George isn't over here, so I'm just not going to send it to anybody. If they were here, then it would only go out the ports that Henry and George were on. So we get segmentation at that layer. Routers are going to be devices that we'll learn to configure, and I think that's what, when we talk about Cisco, that's what people think about is routers. We're also going to do switches. Switches are very important, the configuration of them. Routers find networks, find IP networks, and we'll talk about how it actually gets delivered to the individual device, which is going to be via the layer 2 device. We can filter IP addresses on layer 3, access control lists, which means that we can use this thing to stop traffic or to admit traffic, and you've heard the term DMZ filtering. We'll learn how to do that by writing access control lists. It also creates what's called broadcast domains. Broadcast domains, no broadcast manages all the stations. This is a layer 3 device, and a broadcast is just what it sounds like. A broadcast goes to everything. Switch or hub, a broadcast goes everywhere. A router stops those broadcasts, which means that we're going to have less traffic as we use them to break up our networks. We're also going to get some degree of security by doing this thing. So it communicates among networks, among IP networks. We're going to have communication there. Locations in an IP network could be at a location, a physical location, a building, could be rooms. We used to break all of our rooms up in order to keep the advanced students away from the basic students because they would do some odd things. We broke them up, and then if you have like your payroll, you probably want to make it more secure on its network and have some filtering who can actually get onto that network. It does add some security because everybody can't see everything easily because the broadcast, we isolate the broadcast in those networks. Some internetworking devices, and this tells us what we might look at the kind of network. This would be a moderately small one. A bridge, you may or may not ever see a bridge. Switch is frequently called a multi-port bridge when we do that. So we have routers to isolate the traffic, the broadcasts, and a router is going to be the device that sends our information to our ISP, our internet service provider, to get us onto the internet. And then obviously going to be lots of routers on the internet to get the information from point A to point B, and you probably have heard the commercial, seen the Cisco commercial that the internet runs on Cisco devices, and to a great extent it does. So the principles that you'll learn in Cisco would apply to any of the vendors that you might have, but Cisco is one of the primary providers. Now we got hubs up here. Hopefully you're not going to see those. Most of the networks today are going to be switches. A typical network today, here we show switches, and switches are what we want to be able to use. Switches, vice hubs. We don't have collisions, no collision domains. Routers are used to find the other resources, and here we're going to the internet, or we're going out into our enterprise network, going from location to location. When I worked at Blue Ridge, we had, I think, 10 different physical locations in the network that we had to manage, and we brought traffic back to the headquarters activity to do a lot of filtering, because in a medical world you have to be careful about who can see what traffic and what goes where, who can go to the internet, what traffic can get to the internet, who can get into your network, those sorts of things. So we used Cisco devices in order to consolidate all of our networking needs there. And at ECPI we predominantly use Cisco. We use a couple other vendors for some things, but mostly it was Cisco devices. So a review, we didn't do the course topics. That was in the intro one. We talked about a network perspective, whether you're a home network or you're an enterprise network, or a quick overview of network devices. And yes, there will be more detail and how to manage those devices, the ones that are in use, and that's going to be that's going to be switches and routers that we'll learn how to configure in the course. And then what a typical network in use today is, where we use switches, not hubs, and we use routers in order to connect the different devices together into different parts of the networks together. With that, I'm going to quit on this one and hope to see you in the next one. One of the things that I didn't do, this is the network fundamentals, is where we're going to start, which is 20% of the test. So with that, we'll go with the actual first real, this is just an overview, the first real objective, which is going to be compare and contrast the OSI and the TCP/IP models which are networking models that we'll use in order to simplify our tasks. Anyhow, hope to see you in the next topic. Thank you.